Quantum computers are way more powerful than classical computers, and that's because they have access to special digital code that does not exist in classical computers.
We have now demonstrated using 2 quantum bits inside a silicon chip that we can create these non-classical codes required for a functioning quantum computer. And we have done this with the highest accuracy ever recorded.
This quantum code uses a striking phenomenon called entanglement. You see, in a classical computer, you use as code simply all the possible combinations of the bits that you have available. But in a quantum computer, you can also write quantum superpositions of all the classical code words. And these new code words represent an additional computing language you can use to expand the power of your computer. These new code words have no analogy in the classical world, and they are in fact quantum entangled states.
What we did was to violate a principle called Bell's inequality, which sets a hard limit to the amount of correlation there can be between 2 classical bits. This experiment was done using 2 quantum bits, the electron and the nucleus of a phosphorus atom inside a silicon electronic chip. We first prepare both quantum bits in the 0 state. We then put the first one in a superposition of 0 and 1. Then, we flip the value of the second quantum bit conditional on the value of the first. And now, the bits are entangled.
The accuracy with which we have written these quantum 2-bit code words is the highest ever achieved in any experiment. And yet, this was done using a silicon chip that is quite similar to the one you have in your normal computer. This means we can now expand this quantum computer device, write even more complicated quantum code words, and use them to solve very hard problems such as molecular simulations, drug design, and database search.